Uh, Today we shall discuss some uh, real-time implementation or some use case of Kafka and this Spark. Okay, let me just explain you the flow. Okay, how the data is moving from Kafka to Spark and what we are doing in that. In that flow, what are we trying to do with data? And what is the destination point for the data, final landing area of the data. Let us try to see that part. Okay. Now uh, this is actually the flow. Some Kafka cluster. So in this Kafka cluster, uh, someone has some data will be there in Kafka cluster. So in Kafka cluster, the data will be in topics, right? That is the messages. The message will be in terms of topics. Okay. Now what our application has to do is it has to pull the data from the topic, whatever the so and so topic we have mentioned here, we are going to mention here. So it has to pull the data from a topic, and so what type of data this topic is going to have is some JSON data. I think you have the idea of JSON data, isn't it? You know what JSON data is? What is the format of JSON data?
Yeah, I know.
Yes, fine. So the data will be in JSON format, that is in topics. So we need to design an application, develop an application that has to pull the data from the topics, that is JSON records, and these JSON records have to be, they must be transformed and they must be sent to some RDBMS in the form of so in RDBMS a table has to be created under a database, and this entire data, what the data we have in JSON records, the data must be converted into a table, into rows of a table. So we need to design this develop this application. So what is that tool, or what is that programming we are going to use for developing this application? And that is pulling the data from the topics, and this JSON data to be converted, to be transferred to RDBMS as a table. Okay, that we are going to see now in this session. Okay, Kafka cluster topics, and pulling the data from the topic, and moving it into a RDBMS. Maybe we are not going to see any transformations in between here, just we are trying to convert the data of topics JSON data into a table. We are going to move it into a table. So move how we move into a table, that we shall try to see. Okay. First, let us start the Kafka services in my cluster. So in my cluster, I'm trying to start Kafka services first. The local and Kafka. The first service to be started under Kafka is a Zookeeper, right? Zookeeper hyphen server hyphen start dot sh and config za1 dot properties. So I'm starting the Zookeeper. Yes, Zookeeper has started. The next tab, I will start one broker a server, Kafka hyphen server hyphen start dot sh, and under config server one dot properties. So one Zookeeper and one server. I have started only one Zookeeper and one server. Now, so Kafka server is one. Kafka server one, it has started here. Next, we shall try to see the topics here. What are the topics that are available? Various topics. How do we see the list of topics here? Bin Kafka hyphen topics dot sh hyphen hyphen list hyphen hyphen zookeeper localhost colon 2181. So it will show give the list of the topics that are present in the cluster. There are no topics at all. no topics are there. Mm, let us try to create one topic. Let's try to create one topic. How do we create a topic here? Mm, topics.sh hyphen create hyphen topic one, let us say, and partitions. Let us go with only one partition. Partition TIONS partitions one, and replication factor, let it be one again. So we are trying to create a topic with one partition and one replication, and with zookeeper localhost 2181. Topic is created now. That's fine. Now, the first thing we need to do here is we need to move some JSON data into this topic. We need to move some JSON data into this topic. How shall we move some JSON data into this topic? Topic one. Okay. For this, we have an application already here. Mm, Kafka file 2. This application already we have discussed in the previous sessions. Or let it use Kafka process one. Let us write a simple application to read the data from. mm, so what we are doing is here. Let me just explain that we are trying to move the data into this topic. Into this Kafka cluster. Now here we have one server. Let's just server one, and we have created one topic called as topic one. So this topic one should contain JSON records. Currently, we don't have any JSON data into this. Let us publish the data into this topic by using producer. Okay, so where from this producer is pulling the data? Let's say some file, from some file, some JSON file. It is a JSON file. From it, from that file, this producer is pulling the data. Is pulling data from the file and is publishing to the topics. Okay, that's fine. After that, next we shall see the application that pulls the data from the topic and stores it into RDBMS. Let us see. Okay, that's what I'm trying to do. First, let us develop this producer application and write the data into topic. So let us first create the file. The first thing is, let us create the file. Let us do the file, create a file first. Next, let us create the develop the producer application. Let us run the producer. So it has to pull the data from file. It has to publish to this topic. Okay. Let us develop that producer application. So already we have some sample codes here. Let me create one more file for this, one more program. So under src main scala, it is a package we have. Let me right click on the package and choose new scala object. It's not a class, choose object. Let me call it as Kafka JSON. Subject has created, object is created now here. Let me just copy this entire code because it is as it is. Wherever we want, we shall make those changes. Okay, this is what I have written here. Kafka JSON 2. This is let me add the packages. Alt enter. Next, alt enter. Alt enter. This is not the package. This is the wrong package. Java. Properties. This is fine now. Mm, so this is producer app. Retries from it. Let it be. And bootstrap servers. This is the, what is this? Can you guess? Can you make a guess? What is this? 172, 1638, 131, 9091.
The port address. Sorry, URL
Yeah, Kafka. Okay, that's
9091 is the port.
is
Yeah.
a port number of server Kafka server process. Okay, and this is
Yeah.
172.16.38.131 is the IP address of the server in which the Kafka server process running. Okay,
Right.
right. Let me just delete all this. Is not required. Yes, I think it is fine now. So what is the topic name? What is the topic just now we have created? The topic is topic uh, 1. Topic is topic 1. We have created the topic 1 in Kafka cluster, and the line, I think it is fine now. Let the file be some JSON file. Can you see this? These are the properties. These are the properties that we are configurations that we are mentioning for the producer application. Okay, this is the server, and this is acknowledgement, client ID, retries, batch size, key serializer, and value serializer. And we have a discussion of all these properties in the previous sessions. Okay, so this is the configuration of proper producer. Next, we are creating here a producer object. Here we are creating one sorry, with the statement we are trying to create a producer object. Okay, producer we are trying to create here, and after this we are trying to give the information of the file from which we are trying to, the producer has to pull the data from. Okay, this is the file location from which uh, producer has to pull the data from. Pull the data from. Okay, the location from which the producer has to pull the data from, and this is what this statement is for. Producer publishing. This is for producer publishing the data to home, data to the topic. What is the topic name? That is topic 1. Produce to topic 1. Produce data to the topic 1. Okay, this about, that's it, fine. Now what we have need to make is we need to make this file ready now. JSON file we need to make ready, and later we need to run this producer application. So this producer application has to write the data into the topic. Okay, so this is the path actually on my system. In my system on the desktop I give this path for this file, JSON file. Let me create the file and let me have some JSON data into that file. Here this is the path desktop. Let me create some file here. Some text document. Let me call it as JSON file, and let me enter some manually. Let me enter some data, some JSON records, some sample records. Later we shall try to download some JSON data from directly from internet or from some REST API, and we shall do on it. But for this testing purpose, let us have some sample data. Let me call some name. Let's say Hina, and domain. Let me call it as streaming. Okay, country. Or let me call this is one JSON object or JSON record. Let me take one more name. Mm, Karunakar, domain, ATL, country, India. Okay, this is one JSON data, and let me take one more record. Command, domain, some admin, Japan dataset. Okay, and let me copy the same records and paste them just to have some set of records. I'm copying and pasting them. Okay, let me save this file. We almost have certain how many records we have here, some 20 records almost. Okay, now let us try to run the producer application, so that the producer application has to pull the data from here, from this file. It has to publish to topic. Let us say that whether it is writing or not. mm, no, let us go here, and this is json file dot txt extension is fine. Now let us write this, run this application. Right click on the application editor and run Kafka JSON. And the last, let me write one more here. Mm, Successfully published data to the topic. Sorry, topic. It could be fine. Let us save it and let us run it. So now this producer application has to publish the data to the topic into the cluster. Let us see if this works fine or not. It has to, yes, it has give the signal successfully published data to the topic. Okay, let us just verify in the cluster whether we have the data into the topic or not. Now let us try to read from Kafka console consumer. We shall see whether data has been written into it or not. Topic one, hyphen bootstrap server 172.16.38.131 colon 9091, mm, hyphen from beginning. Yes, we got the data. Okay, the data is being published into this topic successfully. Okay, is it fine up to now, Hina? Any questions from up to here?
Yeah, that's fine.
Right. So finally, what we could do is we could move the data, publish the data into the topic. The next task is we need to develop an application. That application has to pull the data from this topic, and it has to move to RDBMS. It has to move to RDBMS. Okay. So in my server, I have one MySQL RDBMS. Let me use this. So this RDBMS MySQL I have in my machine in my cluster 72.16 hyphen p. Okay, this is the MySQL. Now that application has to directly write the data into this MySQL as a table. What are the JSON data we have? So here, uh, I think here we have written the data.
But why are we link this data, writing this data to the RDBMS? It
Yeah,
is like for big data, no SQL
yeah.
databases are
It,
used.
it, it can be MySQL or it can be NoSQL, any RDBM, any database. Okay.
So we should.
Yeah, yeah. Please go.
So if the process would be the same for the NoSQL.
Slight change will there will be slight change in the code. Slight change.
Okay.
Okay. That the procedure would be same. Whatever the procedure we are following here, the procedure would be same.
But
Where it is NoSQL or MySQL or Oracle or any RDBMS. Okay.
the IP address would be different.
Okay. Right. Let us see that in our next session. We shall try to see that in NoSQL directly. Okay. Here we are going to the RDBMS. Let us go to NoSQL later. Mm, okay. Now here, so data is like this. So if you try to create a table for this data, how many columns you expect to be created in the table? And let's suppose we are writing the data into RDBMS, let's say. So how many columns you would expect to be created in the RDBMS table?
Three.
Three, right? Name, domain, and country, isn't it? So just look into that. Now, fine. Let us create one database. Database has to be created first. Okay, create database, something called as some JSON database, JSON DB. Let me call it as Kafka DB. Kafka DB. Use Kafka DB. Fine. Now, so in MySQL we have created one database. We didn't create the table, just we have created one database. Now let us try to see the application. This is the application actually. Okay. So here we are trying to develop the application. Who is going to what application is pulling the data from Kafka topic and writing into RDBMS? Here it is, Spark application. Okay, Spark streaming application is pulling the data from the Kafka topic and it is writing into MySQL. It need not be MySQL always. It can be Oracle, it can be Teradata, or it can be any NoSQL database like HBase, Cassandra. Okay. Just I'm trying to as a first as it is the first application I'm showing with MySQL. In the next session, I will try to show with either HBase or Cassandra. That would be fine. Okay. Mm, right. So this is the code actually. Kafka. Actually, we have been trying to move it into Teradata, but I'm not using Teradata now. I'm using MySQL. Kafka to MySQL. So these are the some. You have the idea of Spark. Any idea about Spark streaming applications?
Yeah.
Yeah, fine. So I think you can understand this code.
So for the NoSQL databases, I
Hmm.
think the MongoDB is the mostly used.
MongoDB is mostly used, right? I think people are using Cassandra also. Mhm.
Yeah.
Okay, no problem. Whatever we want. So you are interested in going with MongoDB, isn't it?
Yeah.
Yeah.
MongoDB or Cassandra.
Or Cassandra. We shall see tomorrow Cassandra. Okay. So let's write the data to Cassandra. So I think this code is familiar to you. That this is how we create. What do you call as uh, Configurations of the application. First we create some configuration object with spark conf class. Later we create some spark context object and SQL context. That's fine. Don't worry about them, but this is the where this is the part where we try to pull the data from Kafka. This part of the code pulls the data from Kafka. That is pulling the messages from Kafka topic. Kafka topic. Okay, and fine. After this, from here, this is where writing the messages, or data to RDMS or MySQL into a table. MySQL into a table. So what is the table? What is that? We have to specify here. This part, okay. This is the only part that is pulling the data from. Actually, this is the only statement that tries to pull the data from Kafka topic. And which topic? These configurations we have to mention here. ZK stands for zookeeper. Zookeeper, let me give it as, what is the zookeeper? What is the server IP? 172.16.38.131 colon 2181. It is 2181. And consumer group ID, it can be anything, any string, some Kafka group. I call it as some Kafka group, Kafka group. And topic, what is the topic we are trying to pull the data from now? That is topic 1. Okay, it must be a string. Okay, and partition, the partition is, we have only one partition, that is simply 1. That's it. Okay, so when pulling the data from Kafka topic, we need to provide four properties here, four values. One is zookeeper information, zookeeper value, consumer group ID, topic, and partition, isn't it? So this is the statement that pulls the data from the Kafka topic, and finally I am reading the data into Kafka data too. Okay, next uh, this is a Spark streaming coding. This is where we are converting the JSON file. This is JSON records actually, so we are converting the JSON. Do you have the idea of this one called a data frame in Spark, Hina? Data frame.
Yeah, I do.
Yeah, this part, this particular statement is creating a data frame out of an RDD. Okay. So for the messages that Spark is pulling the data from the topic, we need to convert it into a data frame. Okay. This part will convert into JSON frame, and uh, these are the properties. These are the properties of or configurations of MySQL connection. And this is the part where writing the data of data frame into MySQL table. MySQL table. See this one. So this is the MySQL server here. Let me just start as override first. So, so what is the database we have created just now? We have created Kafka JSON, so not sir, Kafka, this Kafka DB. This is a database we have created in MySQL just now, okay? And the table is Kafka DB. And what is the table name we want to create? Let me call it as JSON table, simply some JSON table. Okay. So this is the connection properties. These are the connection properties to MySQL, and this is with this we are trying to move the data into MySQL. Okay, these are the connection statements, and this is the database, and this is the table, JSON table. Okay. Finally, we are starting the application. That's it. Very simple coding. We are not trying to do any modifications or any transformations to the data here. Simply, we are trying to load it. If it is done successfully, then we can, run the application. We can make some modifications or updations or some transformations to this data. First, we should verify that whether data is being written to the MySQL table properly or not. Right. This is what is fine. Is fine. Now, if you try to run this application here, it may not run directly. So this, if you try to run this application now, it cannot run directly. Let us see what is going to happen here. If you try to run this Spark Streaming application, it may throw an error. Array index out of bounds. Do we have any arguments passing here? Are you passing any arguments? For batch interval, we need to provide the batch interval also. Patience and 20 seconds. So it throws this exception here. So the thing is, actually, we cannot run a streaming application directly from this, mainly the integration applications. So this application is about what actually we are trying to integrate Spark with Kafka. Trying to integrate Spark with Kafka. This is integration application. Spark streaming integration application with Kafka. So directly we cannot run from this what you call as IDE. For this, first we need to create application jar. We need to create application jar for this first. Later, we need to submit that application from the Spark submit script. Okay. So how do we create this application jar for this program is let us go to SBT shell. With SBT, we can create that easily. That jar file, application jar file. That's no end of this one. Otherwise, we shall open this terminal. And here with SBT, we can create a jar file, application jar file for it. Simply type the command SBT package. It's going to create a jar file for it. The process going on. Yes, the packaging is done successfully. This is the location.
Creating the jar file.
Yeah, application jar file. For this project, what are the project that we have created in IntelliJ? For the project, I'm trying to create a application jar file. Okay. Uh,
Right.
right. Let me copy the path here. This is a jar file okay, that got created, executable jar file. Let me copy this to the desktop. Now, fine. Now, where from we need to submit the application now to the Spark application? This is called as actually. mm, So from here, actually, we need to, what is the script that we use for submitting a Spark applications? Okay, in real time, what is the application that we, sorry, what is the script that we use for submitting a Spark application? The script is Spark-submit, Spark-submit, and these are the parameters we need to pass the class. So coming to the class, what is the package name here in this? The package name is com.kafka.teradata. Com.kafka.teradata and the class name is Kafka MySQL. Com.kafka.teradata. Com.kafka.teradata and class name is Kafka MySQL. Okay, this is a class information. And along with this, we need to provide this. Okay. Next, we need to provide the path of the application jar file. Just now we have created. What are the application jar file we have created? Let us try to give the path of that. Do this. Okay. I have it on my desktop. Desktop flash. Let me just copy the name of the file. This is our jar file. So this this is the name of it. Dot jar. That's it. Okay. The Spark submit, class name, package.class name, and the application jar. Let us see what happens with this. Even it may throw an error. It has thrown an error. If you try to see the error here, mm, it is showing that comes something is not able to find that Kafka utils, Spark streaming Kafka utils. So in that case, what we need to do is actually we need to add a jar file during the runtime of the application. We need to provide a jar file that is called as when we try to integrate Spark and Kafka. When we try to integrate Spark and Kafka, we need to provide a that is called as integration jar file. That is assembly jar file. We call it as assembly jar file. That assembly jar file we need to provide while we are submitting the application. Then only the integration can be done between Spark and Kafka. Okay. So along with the script, what we need to provide here is, along with the class, we need to provide some assembly jar file by using the parameter hyphen hyphen jars. So I have that application jar file on the desktop itself. Not application jar file, that assembly jar file. Let me show you that. And this is the application jar file. Uh, I don't have here, somewhere it has to be. Maybe I think that I have it in downloads.
Downloads.
Downloads Kafka streaming assembly. Yes, this is a jar file. Let me copy this and paste onto the desktop. Yes. Okay, this is a jar file. Assembly jar file. Kafka Spark streaming Kafka jar file. Let me copy the name of this jar file and provide here. Data, copy it, and start jar. So we are providing two jar files here. One is the application jar, and that is the assembly jar. This assembly jar is for making connection proper, proper connection between Kafka and Spark. And this application jar in which we have our logic, okay, our application logic. So let us try. Let us submit now. Let us submit now. Now this application has to pull the data from Kafka and it has to write the data into RDBMS, that is MySQL. So something wrong, something is happening there. So let us just has been shut down. Something has happened. Let us see what is the problem. Hmm, what is that? Port 9091 broker ID failed. Might be this is down. Maybe this is sleeping now. Let us make this app. This server has went to sleep mode. That is the reason they were not running. Now let us run once. Okay. Let us submit script once again now.
So this is also known as the batch job.
Not bad. It's a streaming. It's a streaming. It's a streaming application. It's not a batch application. Streaming application.
Like we provided the batch um, difference 20
Yeah.
something.
Yeah. 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 Class not found exception com.mysql.jdbc.driver. Mm, MySQL jar file is not able to find MySQL. We include that in MySQL here. I think it is there already. There. That is the problem. Mm, Probably must reset the desktop somehow. What could be the problem here? MySQL.driver. Didn't we mention it properly here in the program? Mm, from.mysql.jdbc.driver. Everything is fine. That's the problem. What is the error? Okay. Actually, here we need to create the table. Actually, the table we need to create the table. Let it be created. Create table, JSON table, uh, name, varchar, something. Next. After that, what do we have? What is of data?
Yeah. Development, I guess.
Domain and country. Domain and country.
Development.
So domain. It is also varchar. Varchar also country and country. Country. Okay, table is created now. Now let us run the script. Maybe this could be the problem without creating the table. It may not work in this version. Now let us run submit the script once again. I think it has to work now. Disconnecting from producer. I think it is still, no, it's not working. Okay, fine. It's a problem here. It's a problem. From.mysql.jdbc.driver. Class not found exception from.mysql.jdbc.driver. Mm, we have included that path, right? Why it is still showing that error? What is there? Everything is there. Overwrite is there. Save more overwrite. df dot mm, sqlc.read.jsnx is there. jdbc dot driver. SQL 1650 double three zero six kafka db db.json table quotes. This fine. Okay, let us do one thing. Let us provide that jar file also. What is MySQL jar file also here. This connectivity jar file. MySQL connectivity jar file. I think we can have it in downloads again. MySQL connected Java. Along with this, let's provide this jar file also. Dot jar. Hope this will work fine now. Okay, let us see. I think it is done now. By Sagate some issue. You have an error in MySQL. Now do have create a table, right? Table is created here. JSON table. What is the table name that we have mentioned in the application? Is it JSON table only, right?
JSON table.
Just JSON table. Kafka.
JSON table.
Yes, yes. Kafka DB dot JSON table. Fine. Kafka DB and JSON table. Fine. Everything is fine. Then how come? Mm, yes, fine. Let us see. That is start from JSON table. JSON table does not exist. What does this mean? Let us drop this table. Drop table, drop JSON table, drop unknown table. Something is happening here.
Did not create.
Not created properly. Mm, what we shall do is something. Let us change the table name here. JSON table 2. Let it be JSON table 2. Let us create the jar file once again. This time. Okay, this is fine. Now let us submit the script. Let us see what happens. JSON 2 has to be created now. Yes, this is on only. Let us see show tables here. In this. So tables are not created. That is the problem. Actually, tables not created. What is the problem? Table has to be created, right? Let us see. JSON table 2 we have mentioned. Let us see this works or not. Whether the table gets created automatically. Let us see. Otherwise, we shall try to create the table once again. The same problem, I think. Table has to be created. Table has to be created. Let us create table. Create JSON table. Create table. kafka dot JSON.
Dot.
Sorry, dot. I did not use dot. Dot. It's fine now. Okay. Let us start the script. What's the problem again?
And then when you selected the tables, it did not show the dot.
Some correlation ID topics and broker ID failed. 1091.
You can try with another code.
Yeah, let me see that. Broker one. We'll do one thing. Every time instead of changing all this, I just instead of hard coding these values in the program, What I do is topic, topic, partitions. Let me just confirm that. Okay, topic one. I got as some arcs of zero and partition arcs of one. That instead of changing every time, let us do like this and table also. Well, MySQL table equal to ARGS of L. So what we shall do is here, what is the topic, right? What we have is this topic. Let get that topic partitions topic. Okay, fine topic is right. So we shall pass this arguments topic, partition, and MySQL table from the command line, from the script itself. Instead of passing every time, instead of changing every time, I think it would be fine if we go with this. Hmm, how shall we call this? Okay, just MySQL table. MySQL table. And let me pass here MySQL table is args2. Okay, let us pass the args2. Let me save this and recreate the application here.
What is batch interval pin?
Batch interval is 20 seconds. For every 20 seconds, it will try to pull the data. It will try to process the data. The Spark
Okay.
streaming application tries to process the data for every 20 seconds.
Okay.
Hope this works fine now.
Are you using the Java 8?
Yeah, Java 8. Not Java, no.
Right.
Yeah, Java 8 only. Yes, Java 8. Java 1.8. OpenJDK. Just a second. It's fine now. Hope this works fine now. Mm, the script now we need to pass the arguments. Okay, we need to pass the arguments here. What are the arguments? The first argument is topic or not topic. Sorry, topic only. Topic name and partition and MySQL table. Topic name is topic one. Argument is sorry. Partition is zero. First partition and what is another one? MySQL table. Kafka DB or JSON table. Let us run this now. One more assertion failed. String zero Java assertion failed. Assertion failed. Just connected to 2181 consumer event thread. This register receiver zero. Started receiver zero. Assertion failed. Let us run the. I think it is one. Sorry. Database name we gave wrongly, I think. Sorry, database means Kafka DB, give capital DB dot JSON table to. Let us solve it now. This is a problem. It's not showing any error still. Not able to create. You have an error in MySQL syntax corresponding to MySQL. What's the problem? JSON table 2. Is the JSON table 2 only, right? Show tables. What is not getting created is getting deleted. JSON table 2. Kafka JSON table 2. Show tables. Again, it is showing some error. Not able to create it. Something is happening here. What's the problem? JSON table 2. What is getting deleted? The table. Otherwise, let us create JSON table 3. Kafka DB dot JSON table 3. Let's create like this. Let us see, does it gets created automatically? JSON table 3 is there. Is the database, is the table there? Why the tables are getting deleted? I don't know.
Why it is showing Kafka DB JSON table without a dot?
Yeah, that we have created, right? Let us do like this. The tables it is there. Let us stop this and run once again. Is it there? Yes, JSON table 3 is there. Let us see. Still showing some issue here again. I don't know what's happening to this table. They are getting deleted here. Kafka dot Overwrite of dot overwrite. Is it because of overwrite or is it because of this one? I think there is some problem with this Spark version coding here. I think I did not do coding properly here. Somewhere it is somewhere I am missing the code. Somewhere I am doing some mistake in my code. Save mode dot overwrite MySQL table prompts. Mm, what if I do this? This is the last attempt we shall do. Otherwise, I will try to show it tomorrow. What is this? The next session. Let us do for this one change, and let us try to create that file once again. I will tell you if this works. I will explain you what might have gone wrong. Yes, it is done. Mm, this is jar file. Sorry. Copy this jar file and paste onto this file. Now let me run once again. JSON table 3. Let us see. JSON table 3 isn't not there here. Show tables. Let me get JSON table 3 now. Show tables is there. Yes, I think it is working now. Mm, let's see. I think it is start already run. Select start from uh, what is table name? JSON table 3. No, nothing is there in this. Mm, let us submit last time. It is not receiving any data. It is working fine, but is not receiving any data from Kafka topic. What is the topic we have seen here? Topic one only, right? Topic. What is the topic name? They're passing it.
Topic one.
Yes, they're passing it as an argument, right? Yes, they're passing an argument. Let us see that. Yes, topic one only. Yes, that's fine. Topic one, that's partition, Kafka DB, JSON table 3. I think it's fine. Let me just verify Kafka console. And consumer dot sh. I think I can topic topic one. Can I open bootstrap? Sorry, I think you have to run the producer once again. No, no, fine. It's fine. Okay. Now we shall run this application. Now what we have to do is we have to start the producer now. Actually, we have to run producer application also. It is going to write now.
Okay, sure.
Uh, yeah, now fine. Now let us run the producer. Kafka JSON.spinner.
We didn't run the publisher.
Yes, producer. Now if you run producer, this producer now will write the data to Kafka topic, and the Spark application is already running. That will pull the data from the topic, it writes to RDBMS. Run this now. So once producer runs successfully, once publishes, the Kafka has to pull it and write to RDBMS. Let us see that.
So first we forgot to
Yeah, yeah. Produce,
run
produce.
publisher. Produce.
Writing. So it is saying that successfully published data to topic. Let us see whether it has written the data into this table or not now. Yes, so it is now it is written. You can see here.
Yeah.
Start from JSON table. That is what we are missing this time in right this time. Right. So
Right.
whenever again, if we how many rows we have seen now, 21 rows now. Now if we run the producer once again, and if we run producer once again, let us run once again the
40,
producer. How many?
42.
Yeah, 42 exactly. So successfully published. Now if you try to read them. So not yet written. I think it is still in writing process. So now it is there. Okay. Now we got 42. Why this latency? Why this delay here?
Yeah. Fine.
Yeah, we gave 20 seconds for processing, right? For every 20 seconds, Spark will
Okay. It is
process.
waiting. Right.
Yes, yes. For every 20 seconds, Spark processes and writes it into RDBMS.
Right.
This is what. Is it clear? So,
Yeah.
the thing is, you need to practice in a compulsory. Okay, you need to have
Yeah.
an
So like you told me to download the sandbox, right?
no need.
Coding works.
Do you have
Coding
Cloudera?
work.
Hortonworks, do you have Cloudera?
No, at the moment, no.
Then, if you have this RDBMS in your Windows, that's fine. Or NoSQL in that. And we need three things actually. What is that? We need Kafka, we need Spark, and we need NoSQL or RDBMS. So where are you going to install
Right.
all this?
And can I have some guidance for the Horton work?
Okay, you can do from Hortonworks. Okay, you can either that's what I'm asking, telling you. You can go with Hortonworks or you can go with Cloudera. Because this is the
No,
yeah.
yeah, I just needed the guidance how to do it.
Okay, yeah, that's fine. Okay, yeah, but try to verify whether everything is what you call it installed properly and the proper versions. What are the versions I am
Yeah.
showing you here? The Spark versions and Kafka versions. We can change the code according to the versions. We can change the code, but whatever the program I have shown, I'm showing you now. These are the versions of Kafka. Let me just list the versions here. Here, Kafka version 2.10 and the Spark
Okay.
version mm, 1.6.3. I have used 1.6.3. Mm, and MySQL with the 5.7, I think 5.7. Okay, this is what I have used in my. This is in my application. I have used this.
I think I have 6.3 MySQL.
No, it works. That is not a big issue. Just I'm telling you, this is what I have used in my application now, just now. Even though
And what
if the Kafka version changes, Spark version changes, MySQL, that doesn't matter. We can change the code according to the versions. That's not a big
Okay.
deal.
And what about the name NoSQL? Wh-
Yeah.
What is
Mm, let us go with the Cassandra. Let the Cassandra be installed. I think better go with. I think what is the version? I do not remember what is the latest version of Cassandra. Let us just check out.
so?
Apache mirrors. Cassandra. Cassandra. Uh, this is the latest version. Latest
0.1.
3.11.12. This is the latest version, I think. 11.2. Just
Should I
start.
do this?
Yes, go with this.
Okay. And
3.11 star file.
okay. Should I also download the MongoDB?
MongoDB is not a product of Apache. You need to download. Do we have open source? This is not a product of
Yeah.
Apache. If you have open
I,
source, just
once.
you can download it. You get it downloaded. We shall work on that. It's not a big deal. Fine.
Right.
Fine.
So.
So I suggest you go with Kafka version. It is fine, but Spark version. Do not go with 1.6.3. No one is using the rare. The already some projects are developed. They are going with 1.6.3. But newly developed projects they are going with some two versions. Spark version 2. Let us go with some 2.2.0 or some 2.2.1. This Works is using
Blake.
2.2.0.
Okay.
Okay, let's go with that version. And Kafka and Spark was the Cassandra. What is the 3.11, right? It is 11. 11.
So at the moment I have 8 GB.
Mm-hmm.
So should I go for this?
Yeah, you can. If you have an issue, even you can install all this on your own. Okay, just download what you call as. If you have Cloudera, you can download the Cloudera or Hardenworks. Otherwise, if you can download, if you can create a backup, call as VM image of this Ubuntu, then I can show you how to install all this and we can work all this. Then you
So
will
like
get.
on Ubuntu, the Hotelworks or Cloudera, they can be downloaded on VMware.
Yes, we can. We have the VMwares, right? We have VMwares for
Okay.
all these. Let me show you that. Sandbox, you can download the sandbox or you can download Cloudera, VMware image, anything.
Okay. Right.
Download.
From this site only. Should I search it
Yes.
in
Okay, fine.
okay,
Okay,
Apache
thank you.
Mirror?
Okay, thank you, Hina, for the session.
Okay. Can I ask you like apart from this,
Yeah,
I
yeah,
have two other questions.
yeah,
Like, can I add this on my resume? Whatever so far we have
yeah,
studied.
yes, yes. But we have to do it in a some larger scale. Okay, this we have seen very simple data and with simple coding. Let us add some stuff to it, this stuff to the, like making some transformations to the data in Spark itself. The JSON objects are very simple JSON records, they are with only some three fields. Let us take some complex JSON data with nested
So,
JSON.
so after like, when should I be able to add this on my resume?
Okay, just give me 2 days time. By Monday I will
Okay.
give you the entire documentation as well as uh, I will try to add the stuff what is that is required for keeping
So,
it as a project.
right, right.
Okay?
Because I just want to update my resume. In the meantime, we can go on with our lecture
Yes,
session.
yes, yes, yes.
But I and kindly, if you could help me for
Mm,
uh, the updation of the resume, just
sure, sure, sure. We will do it.
right.
Okay, just give me
Okay.
2 days. I will prepare. I will get everything ready. Okay.
Right, right.
Thank you. Thank you for the session.
Okay, thank you very much.